Hello. In this video lecture, I'm explaining about the wave properties of the matter. We'll look at a water wave, sound wave, and the light waves. So what is wave? Wave is motion in the propagation of energy by means of a disturbance in a medium or through space itself. There are two kinds of waves, mechanical wave and electromagnetic wave. Mechanical waves involves energy propagation through an elastic medium. But in case of electromagnetic wave, no medium is required to propagate through. Okay. So in this lecture, we will see the water wave, then sound wave, and then light wave. Okay. So to begin with, let's see this water tank. First of all, let's set off the experiment. So we are looking from the side view. Click on here, and then this wave, top box, top left. Click on normal view. It's already there. So if it is not, click on the normal view. Then here is the amplitude. You can manipulate amplitude from 0 to the maximum. Set this one maximum so that amplitude will be maximum. The wave amplitude that produced by the wave will be maximum if you set the maximum amplitude. And let's test with the minimum frequency. Okay, if you click this green button, look at the wave generated. Okay, and also you can see the graph here. If you click on the graph button right here on the right, we can see the graph of the wave. Look at the graph. Main thing you have to observe here is the wavelength. How long is the wave? We can measure the wavelength by using this one. Look at here. For example, from here to let me stop some wave and look at. Okay, so for example, if this is the crest, the top of the wave to the another successive top right here. So tentatively this one. Okay, it looks like 7 centimeter. Okay, if I keep it here and increase the frequency of this wave, set it to maximum, and try again. Try again to okay. Look at here. What happened? What's the sense? Okay, so if I stop here and again measure the wavelength is this one, right? The distance from one crest to the another successive crest. So this one is nearest the crest, right? Right now it is 1.7. Look at here, what happened with maximum frequency and minimum frequency. When frequency is minimum, wavelength is maximum, right? That was 7 centimeter. When frequency is set to the maximum, all the way right here, max, then wavelength of the wave decreased. That is 1.7 centimeter. That is significant decrease in the wavelength, right? It shows the relationship. The wavelength of the wave is inversely proportional to the frequency. That means if you increase the wavelength, frequency will be decreased. If you decrease the wavelength, frequency will be increased. This is just opposite relationship. Okay, so that's what we saw here. Also, you can observe if you put this box right here, bring it somewhere here, and put one here and another right here. Let's begin again. Okay, just wait a minute. I'm just producing one wave and see what will happen. Just put it somewhere here and somewhere here. This is for looking intensity of the wave. If I put one drop here and then stop it, look at here. What happened? this wire here is measuring the intensity, that is the amplitude, right? Amplitude of the wave. And this here is measuring the amplitude at this side. Okay, so if you look at these two waves, intensity is decreasing as wave passes through the medium. What happens is intensity will be decreased, right? That's why, if you are speaking from the far, we can't hear clearly, right? If you are nearby, you can hear it. In case of the sound wave, same thing happened with the water wave. Okay, so these are few observations you have to make for the sound. Now your goal is to measure the wavelength and the frequency. Then you can calculate the velocity. Okay, so to measure the wavelength and the frequency, what is the wavelength? Let us measure this one. Okay, we don't have to go. Uh, Let me put somewhere here and get wavelength. Okay, let it go, and then one wave, generate a wave, then okay. So to measure the wavelength, I have this one. What is wavelength? Is the length of one complete wave, and I can measure the distance from one crest to the another crest, or from here to here, right? Here, this is the one wavelength. How much is this? This is 0.9 centimeter, right? So this is the wavelength of this wave. So, we cannot directly measure the frequency in this setting, but what is frequency? Frequency is number of oscillations in 1 second. So let us see how much time does it take to complete this one wave. Okay, if you look at somewhere from here to here, this is one wavelength, right? From here to this point, so this is one wavelength. It's better to measure here. I think it's better than the previous measurement of the wavelength. Okay, so this is one wavelength. So this is 0.7. That's right. 0.7 centimeter is the wavelength. So if you look at from here to here, that is 1 second, right? So tentatively, not this is not accurate value, but you don't have to be accurate. Just tentatively, the frequency is 1. Frequency is 1. So you can calculate the velocity of the wave uh, by using this formula. Velocity of the wave is equal to wavelength multiplied by frequency, right? So in this case, you can take your own data, but I can show you our wavelength was 0.7 centimeter. It has to be converted into meters, so divided by 100 will give you 0.007 and then multiplied by 1. So because second is in SI system, you have to be consistent with the system. Okay, 0.007 multiplied by 1 gives you same number, right? 0.007 meter per second. So this is equal to 0.007 meter per second. So this is here velocity of the water wave, and this is reasonable. This is a small value and it is reasonable. Water wave does not move that much fast. Okay, now let's check same thing with sound wave. If I click here on the sound, let me go back, clear everything from here, and then if I go back, put it back, put this box also back, and let's go to the sound wave. What will happen with the sound? Okay, if I click on graph, play tone, both, and play here, right? And if I make sound on, okay, listen the sound. Okay, so first let me make this frequency minimum. Listen the sound. Observe the medium particles, what they are doing. If you click on side views or top view, it doesn't matter in case of the sound wave. Right now, just listen the sound when frequency is minimum, right? Let amplitude be maximum. We are able to, if you click on both, we are able to see waves as well as particles. If you just click on wave, wave only will be seen. If you click on particle only will be observed. And if you click on both, you can observe waves as well as particles. Okay, so listen this sound carefully. When frequency is minimum, it's a dim kind of sound, right? If I increase this one, notice the distance and explain what is the difference. What is the difference in the sound intensity? Okay. Also, you can explain the nature of movements of the medium particles when wave is passing through it and when it is not. For example, right now, wave is passing. That is, sound wave is passing through the medium. What are mediums doing? Somewhere there is compressed, particles are compressed. For example, right here, this point, look at here, all the particles are coming together. That is compression, right? Some other points, there is rarefaction here. The black, dark ripples. These are called rarefactions. The rarer medium is there, right? So if there is no medium, no sound, I can click on this green button and turn off sound. What is the difference? So when you are speaking, medium particles will act like this. We don't observe, but medium particle will behave like this. When you are not speaking, that means no sound in the medium, in air, medium particle will be like this. Okay. So this is about the sound wave. Now let's do same thing about the light. Click on the third option right here, and top view or side view doesn't matter in this case. Also, we are looking in normal mode, and we need graph, screen, if you need a screen also, and let's put sound effect as well. Okay, so this is the interesting part. We are going from something physical to the very abstract. Light is very abstract. It is very difficult to grasp the properties of light. Okay, so first job here is to measure the intensity of red light. In a white light, there are different colors ranging from violet to red, right? We can say, but we are measuring just some measured hues that we can easily see here. Okay, so one is red starting from this side. I can put it somewhere, the most red for this cursor. And now I'm going to measure the wavelength of red light, because wavelength of different color of light is different. And then I will measure the wavelength of green light, then blue light, and violet. Okay, so first thing is measuring the wavelength of red light. So to measure the wavelength, first of all, produce wave, right? Okay, stop it and measure the wavelength. Wavelength is the length from the crest to the successive other crest right here. Okay, if you look at here, how much is wavelength? Is 655.7 nanometer. So this is in nanometer. You know the nanometer means? If you don't know, let me write it down for you. So nanometer, 1 nanometer is equal to 10 to the power -9 meter. This is really, really small scale of the distance. Okay, so wavelength of red light is very, very small. That means 655.7 multiplied by 10 to the power -9 meter. Okay, so this is the wavelength. You have to find the velocity of the light. If you know the frequency, you can easily find it. How can you find the frequency? You can Google it. You can search through internet, and if you type frequency of red light, you will get it. Okay, and then what is velocity? Velocity of light is denoted by c and given by frequency multiplied by wavelength. Okay, so wavelength, you can use this value, and the frequency you will get it from Google. Okay, so in this way you are able to measure velocity of light, which is the maximum velocity, possible velocity in the universe. So your value should come something 3 into 10 to the power +8 meter. Okay, so you should get this value, make sure. So this is one thing. Now if you go to the green one, what will happen? Let me put this cursor to the green, and again do same thing. If okay, it's enough. Okay, so let me measure again the distance. That is the wavelength. How much is that? For the green light, it is wavelength lambda is equal to 524.9 nanometer, which is 524.9 into 10 to the power -9, right? So what happened in comparison to red light? Does it increase or decrease? If you look at this data, the previous value for red light is 655, right? 655. This is 524. The value of wavelength decreases, right? So again, let me go to blue one. If I move this one to the complete blue, and again do something, same thing here. Look at here. Sound is also changing, right? Okay. Let me measure this distance from here to here. Again, it decreases, which is 437.9. 437.9 nanometer, right? 600, 500, and 400. It's continuously decreasing, right? And finally, move this cursor to the violet and repeat the experiment. Stop it, and then again measure the distance. That is the wavelength, which is 300 for violet, 375.7 nanometer. So what is the pattern? This is the interesting pattern, right? As you move from red to the violet, wavelength is decreasing. That means frequency is increasing. That's why you understand why white light has different color. When it passes through the prism, all the colors separate because frequency is different. Frequency and wavelength for all different colors is different. So each color has separate frequency and wavelength. That's why they bend when passes through the prism. They bend with different angle and we are able to see rainbow, all the colors. Okay, you understand why when we pass white light through the prism, we are able to look at all the colors. And why not when they are moving in space? Okay, so this is very useful information for you. And you can compare, the wavelength and the frequency, what happened as you move from red to violet. And when light dispersed through the prism, why we are able to look at different colors. Hope you could understand.